Hello. It's time for another, I guess, lecture. This is going to be a fairly short one. So what we are going to do today is to get into basic control structure, and there are a few side topics, that are necessary in order to kind of fully explain the basic control structure of not only JavaScript. By the way, this also applies to PHP, C, C++, and Java, and many other languages. Certain things only apply to JavaScript. For the most part, however, what we'll be talking about today does apply to just about every programming language that are C, C++ based. And there are plenty of these languages out there. Alright, so let's go ahead and get started. Um, so for today's lecture, it is helpful that you will find that you have a JavaScript environment, because the kind of script that we are writing is complex enough at this point that it will be helpful to actually write the script in a file and then just kind of run it to see what it does. Alright, so what I'll do is I am going to find my terminal that has the large text, which is right here. And what you see here, is the code that we have been using already. So we're not gonna do that. Okay, so what this particular lecture is not specific to generating HTML pages or to parse the request coming from an HTTP client, basically from the browser. We'll get to those later. Okay, but what we'll be focusing on will be the control structure themselves. Alright, so let's go to a temp folder and let's clean up this screen. It's kind of messy right now. And we're going to create a folder called control structure. And then I go into the subfolder. Now, obviously, I do this because I'm creating these sample programs on the fly, but you don't have to do this. Okay, so you can basically practice this using any environment. You can use the Power Server, which is a very easy to use environment. Other environments may include Replit, where you can just kind of create your program on the fly and not have to install anything. So all of these programs will work in the Replit kind of environment, and I'll show you how to get to Replit in just a moment. Alright, so the only thing about Replit that I do not really like is I cannot use my favorite editor, which is NVim. So we're going to create, we'll first demonstrate a few really kind of important points. The first one is going to be comma separated expressions. So I'm going to call this one comma.js, and we'll go ahead and just do a few things. So we'll say console.log. And in this case, I'm going to use double open parenthesis. This is not a typo. The reason why I'm using double parenthesis is if I don't use the inner parentheses, it's console.log is going to look at the values that are comma separated as parameters. But I want to treat the entire comma separated expression as one single value. So this is the code. Okay, this is the first console.log, and what it's going to print is just 4, and that has to do with a comma expression is essentially just a list of sub-expressions where only the last value becomes the value of the entire expression. So the next one is going to be slightly more complicated, but I think you're going to get the answer right away. So we're going to have 4, 5 plus plus 6, 7. And the second line is going to, the first comma expression, which is this one here, is going to use the value of the last expression as the value of the entire comma expression. So that's going to be the 5. The second comma expression is 6, 7, where the last sub-expression is 7. It has a value of 7, and that's why 6, 7 as a comma separated expression is going to have a value of 7, because every comma expression is going to basically have the value of the very last item of the comma separated list. So the next one is going to be even more interesting. So I'm going to have console.log, and in here we have console.log itself, and we're going to put ABC here, and comma separated, and then we have DEF over here. All right, so this one is rather interesting because what is happening here is, as it turns out, console.log, and when you supply the actual function call itself, it is an expression. It is not really a statement, it is an expression. And as an expression, it becomes a component. It can become a component of a comma expression. And in this case, it does. It becomes the first sub-expression of the comma expression that uses this particular comma here. So what JavaScript is going to do is to evaluate from left to right. So the first thing it evaluates is console.log with ABC as its argument, which will end up printing ABC on the screen followed by a line feed character. In other words, we'll be ready for the next line. When this expression is done, then, as in the case of a comma separated expression, is going to evaluate the next sub-expression in the comma expression, which in this case is DEF. So DEF is the last expression, the last sub-expression of the entire comma expression. So that becomes the value of everything that I'm highlighting right here. So this entire thing has a value of DEF, which in return is being used by the outer console.log to print out DEF. So the end result of this particular line is going to first print ABC, followed by a line feed, and then followed by DEF. All right, so let's go ahead and let it run, right? So we'll say node. Actually, I really don't need to call this. Interesting. Let me clear the screen because it went back to something from before. Alright, so there we go. So now we have commerce.js as the name of the program. So now we have node commerce.js. And as the program runs, it has 4, 12, ABC, and then DEF. Now, if you just want to look at a very short program without getting into an editor, which is kind of there are a few more steps in doing that. You can use the command called cat, which actually stands for concatenation, and then followed by the file name. And this is going to show you the content of the file. So the first one is printing 4 because 4 is the last of the comma separated list or comma separated expression here, and that's why that becomes the only value that console.log is going to print. The second one prints 12 because we have 5 coming from the first comma expression, and then we have 7 coming from the second expression. And when you add 5 and 7, we have 12. And the last one, which printed ABC and then DEF on separate lines, we just explained that one already. So you might be wondering, why am I talking about comma expressions when the focus of today's lecture is on control structure? That has to do with, this makes it possible for me to illustrate how JavaScript runs a particular control structure, because I can now insert console.log just about anywhere I want to insert console.log, because as we can see here, console.log is its own expression, and then we can use the comma expression to basically say, okay, let's print this, and then we'll do something like this, and then we'll do something else. All right, so the next one is going to be, I'm going to start a new program here. We'll call it Commerce1.js. So with this one, we're going to have some variables. So even in a global scope, there's no hurt, there's no harm. There's no harm in using the word let. Okay, so even though most people use var, let is really kind of, I think let is a better keyword to use. There are differences between a var versus a let, and I think let is a more useful specification compared to var in most contexts. So in this case, we're going to have, we have x, we have y as 2 separate variables, and then we'll just do a bunch of consoles. Okay, so we're going to say console.log, and we'll first print out what is the value of x, which is going to be undefined. So I predicted this is going to print out undefined. The // by the way, is how we start comment on the line, and basically the comment extends all the way to the end of line if it is started by //, but it does not continue onto the second line. So the second line is completely starting from scratch here. It's not a continuation of the comment. Alright, so we're gonna do something else here. And then we're gonna say console.log. And this time we're gonna have an assignment statement. So we're gonna say x equals to 5. Okay? And this we have talked about already. The assignment is an expression, it is not a statement. So x equals 5 is really an expression. It just has the side effect of updating whatever is on the left hand side of the equal symbol. And the value of the expression is whatever is on the right hand side, which in this case is really just a constant of 5. So it's going to print 5 in this case. So the next line, I'm going to do something even more fancy. Okay, this time I'm going to give y a particular value. So y is going to get that value. But also at the same time, I want x to increment by 5. I want the value of x to increase by 5. So I'm going to say x equals to x plus 5. And this is going to print 10. So what is happening here is we are using the parentheses, by the way, are not necessary. Let me specify which pair. So this open and this close parentheses are really not necessary because assignment is what we call right associative. In other words, it works from right to left automatically if you do not specify extra parentheses. So what is happening here, as usual, okay, when you see a whole bunch of parentheses, we start from the innermost part. So we start with the innermost part, which is here, right there, which is an assignment operator combined with an addition operator. The assignment operator cannot do its work until it has evaluated the right-hand side. So when we evaluate the right-hand side, x already had a value of 5. 5 plus 5 is 10. So the entire right-hand side is the value of 10. Now the assignment operator knows, oh, okay, I know what the value of the right-hand side is. Now it's time to update whatever is specified on the left-hand side. And in this case, left-hand side is also x. So at this point, x is updated to a value of 10. But because assignment is also an expression, it has its own value, which is the value being used to update the variable. In this case, it is 10. So this entire thing, okay, everything that I'm highlighting here, this entire thing has a value of 10, which is then used to update the variable y. And then this entire thing, okay, the entire thing inside the parentheses of console.log has a value of 10, and that's why console.log is going to print 10. It just has the funny side effect of x is going to get a value of 10, and so is y. Okay. Alright, so far we haven't really seen anything about the comma expression, right? So let's try something here that is going to make use of the comma. Alright, so remember, every time you want to test a comma expression inside console.log, you kind of have to use an extra pair of parentheses to emphasize that your console.log should only look at the result of the comma expression itself and not to treat everything in a comma separated list as its own parameter being passed to log. Okay, so what we'll do here is this time we're gonna update x and y independently. So we're gonna update x to be the value of say 17, and we're gonna update y to the value of 21. There we go. So in this case, it's going to print 21, and that is because it will first evaluate this particular expression. This expression has a side effect of updating variable x to 17, and it has its own value. The expression itself, the entire assignment expression, has a value of 17. But that value of 17 is actually being tossed away because it is the first item. It is not the last item of a comma expression. So the next expression inside the comma expression is y equals to 21. It is an assignment expression. We evaluate the right-hand side, and then we use the value of 21 to update y, which is a variable. So that's the side effect of an assignment expression. But the assignment expression itself also has a value, in this case, of 21, and that turns out to be the last expression in a comma expression. And as a result, 21 becomes the value of this entire thing, which is then printed out using console.log. Alright, so let's check out whether my prediction is correct or not. Okay, so we're going to say node commerce1.js, and then we take a look at the code again, right? So this way, we can kind of double check and see whether the prediction was correct or not. The first one is undefined, which is here. The next one is 5, which is here. The next one is 10, which is here. And then the very last one is 21, which is over here. Alright, so I'm hoping that we are now getting an idea of how assignment as an expression is important and how comma as an expression is also important, because now we have a way to combine a bunch of expressions into one single larger expression. And because that larger thing is still considered an expression, it can now go any place where an expression is expected. So you might be asking, where are we going to be using this, right? So let's go ahead and look at the next program, which is going to test the concept of if then else. So I'm going to just call this if.js because it's going to test a conditional statement, and I'm going to borrow the code coming from the written module. So we're going to write a function that finds the maximum of 3 different things. So we're going to say max 3. And the 3 different things here are x, y, and z. And if x is less than y, then we do this. Otherwise, we do this. Okay, and we may want this to return something, or we may not want it to return something. Let's just say that we want it to return the maximum of the 3. So now we want to maintain a local variable to the function, and we'll call that the result of the entire thing. So result is uninitialized to begin with, and hopefully throughout the execution of the code inside max3 we'll have it to get some useful value. And then don't forget to say returned result at the very end, because otherwise the function returns a undefined value, which is not the intention here. We do want it to return a result here. So inside here, if we ever get into this branch, it is because x is less than y is true. If x is less than y is true, that means x cannot possibly be the maximum. It has to be between y and z. So we just have to compare y and z at this point. And by the way, this is this kind of funky way of writing code, where I just define the skeleton and then go back in to flesh out, the content. This is actually how I write code in general, and I find this way to be quite useful because this way I won't forget the close braces, and the indentation will look right from the get-go. So just a little tips, from someone who has coded a lot. Okay. So in this case, it is nested, which means if I ever get to this point where the cursor is, it means x is less than y and y is less than z. So that means z has to be the maximum. So now we can say result equals z. And if we get to the else case here, that means x is less than y, but y is not less than z. If y is not less than z, y can be greater than or equal to z. But if y and z are both greater than x, hey, I can pick either one of those as the maximum. But since y can also be greater than z, I should probably just use y as the result here. And then over here, if I get to here, that means x is not less than y, which is also the same as saying x is greater than or equal to y. So that means y is not going to be the unique maximum. X can be the maximum, or z can be the maximum. So now we have to compare x and z. Whoops. Use the wrong brace. That's not a brace. So now we have everything in blocks. So if I ever get here, that means z is greater than x and x is greater than or equal to y, and as a result z is going to be the maximum. So we say result equals z. And if we ever get to here, it is the other way around. X is also greater than or equal to z, in addition to x is greater than or equal to y, so x is the maximum in this case. So result equals x. There we go. And then outside of the function definition, which is exactly where the code is going to start executing, now we can say console.log, and we want to find max3 of, let's say, 617. and then we'll say console.log, and this time we'll say max 3, and we have let's try to trick the program. Okay, let's see what it's going to do when they're all the same values, right? So you can probably imagine that you can kind of test this code and say, okay, let's see if we can handle the case when 2 of the values of the 3 are the same, and so on. Okay, so I'm just going to test you with these 3 examples here. So the first thing is I'm just going to run the code and see what it does. So node if.js, it prints 7, 5, and 6. So now we want to go back and look at the code again, and of course, we lost the output 7, 5, and 6. 7, 5, and 6 are indeed the maximum of each one of the cases when we are testing max 3. So this is great, right? So now the question is, I'm not really sure about the path of execution here. Now you can just insert, okay? You can insert a whole bunch of console.log if you want to, and let me show you what I mean by that, okay? And because we know, a comma separated expression can go anywhere where a value is expected. So we can actually, if you want to say, console.log, and I'm just thinking about whether I want to throw in the backtick notation here. I'm just thinking. It's going to be a new concept because I have not talked about the backtick concept. So from that perspective, I'm hesitating a little bit. But on the other hand, it's a very cool concept, especially from the perspective of, oh, how do we print out the value of x and the value of y here? Well, I'm going to do it. Okay, so let's go ahead and learn about the backtick notation. So the backtick notation is, as I said, just a backtick, which is the unshifted version of the tilde backtick symbol on your keyboard, which is at the upper left corner, right under escape on most keyboards. So a backtick can also be used to quote a string. The difference, so I'm going to do it like this, just to remember that I need to end the back quote string, and I need a comma after that. So now I'm going to go back to type in the content of backtick. So you can type in some regular stuff, okay? So we can say outer if, okay, just like that. And this one we'll say console.log, and then same thing using backtick, because we're going to populate your backtick with something that's really kind of fun in just a little bit. So now the question is, how am I going to call this particular conditional statement? It is nested inside the outer conditional statement, but there are 2 nested conditional statement. The other one is down here, right? So the question is, how do I designate this one so that we can specify which one it is? So I'm gonna say this one is the this is the then branch of the outer conditional statement. So this is gonna be then if, okay, and that's gonna make this one the else if. Alright, so we say the same thing, console.log, oops, backtick else if. So the else is referring to the else branch of the outer if, and then the if means this is the beginning of an if statement itself. Okay, so let's just check this out. Okay, this is another tips about writing code is don't try to write too much code without testing it, because if you make an assumption and go like, yeah, I think this is going to work, I think that's going to work too, and then you write up like 15 lines of code and then you test it and it doesn't work, then you know that some of the assumptions about, oh, I think this is going to work, was not true. But which one was it? It becomes kind of difficult to find out. So my advice, at least for people who are starting out to program, is don't write too much code. Test run it and then test again, and then add something or change it a little bit and then test again. All right, so this is the program, and we're gonna say node if.js. And now we have some additional statements. So the first one, which printed the 7, which got the maximum of 7. started it with the outer if statement. I mean, that kind of goes without saying because the only statement of the function is the outer if statement. But then it went to the conditional, it went to the else side in order to find the value of 7. The second one also went to the else side, and then the last one went to the then side. Alright, so this looks kind of fun, right? I know some people may not consider this fun, but it is kind of fun. So you can kind of imagine that you can even insert more console.logs into here, okay? So if I were to insert a console.log here, it would be inside the then, and this is going to be inside the then of the then, right? And then this one over here, oh, I forgot one. So this one over here is going to be it starts with a then, referring to the then of the outer conditional statement, but then this is the else of the nested conditional statement inside the then branch of the outer conditional statement. In case people are asking, this is considered the outer conditional statement, and this is considered the nested conditional statement inside the then branch of the outside conditional statement, and this entire thing over here is the else branch. Oops, sorry about that. This thing here is the else branch of the outer conditional statement. So I could just insert a whole bunch of console.logs just to find out how the program executed, right? So I can say console.log. This is else then. Oh, forgot about the backtick. Else then, and I'm just going to copy and paste here because I'm not patient. I don't want to type everything myself. So now, and when we run the program, we get more detail of how the program ran. All right, so the first one went to the else branch of the outer conditional statement, and then went to the then of the nested conditional statement that is inside the else branch of the outer conditional statement. This one went to the else of the outer conditional statement, and then in the conditional statement that is nested in the else branch of the outer conditional statement, it also went for the else branch, and so on. Okay, so you look at this and go like, wow, that is a lot of work just to track down how a conditional statement works. You're right, this is a lot of work. So let's see whether we can do something to reduce the amount of work. So this is also something that I did not talk about in the printed text because that's about control statements. It's about the concept of a control statement. What I'm illustrating here is kind of the lab stuff, right? This is the kind of stuff that you can do with hands-on stuff. So how do we do all this without all of those console.log? Even though it's really helpful, there has to be a better way to track down the execution of code without using a whole bunch of console.log, because you have to type in those console.logs into the program itself, which is not very user-friendly. So let's get rid of all the console.logs, and you look at this and go like, oh, that's going to be difficult, right? I mean, to get rid of all the console.log. Well, let me think about this. There's probably a way to do this that makes it not so complicated. So what I'm going to illustrate here, which you don't have to learn, is the power of regular expression. So instead of deleting stuff right away, I am just going to specify a search pattern. And in VI, starting with a slash, means I'm now specifying something to search for. But this is what we call a regular expression. So regular expression, you can just have literal text. A dot has a special meaning, so it has to be escaped, and then a log, and then open parenthesis, and then now we have a problem because what's next, because we want to remove all the console.log, but what is next kind of depends, right? We just have a whole bunch of blah 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 until we get to the close parentheses, right? So the way to specify this is to use a wildcard character. Okay, a dot basically matches anything. Okay, a dot matches any character, and then the asterisk specifies as much as possible. So, but I really don't want to specify as much as possible, so I want to specify close parentheses here. But you can see the close parentheses is not really helping because it's doing a greedy search. In other words, it's searching all the way to the last close parentheses, and not the nearest close parenthesis. Oh, okay, so let's find out how to search for the not the closest close parenthesis here. So I'm just looking up on the side here. I'm looking up vim regular expression non-greedy. And yeah, I do apologize that I'm searching for stuff, on the fly, because I didn't quite plan to talk about this, while I started off with what I'm talking about in this particular section. So I am going to, aha, okay, so I got it. Okay. Cool. Oh, okay, I just found out how to do it. So if you want a non-greedy, but as many as we need to get to something, it is open brace, backslash open brace, and then a minus, and then close curly brace, and then we put a close paren here. And you can see how it is now looking for the closest close parenthesis, and not the very last close parenthesis. In other words, we make the any number of not greedy in this case. Now remember, if you don't want to learn this stuff here, it's not a problem. You don't have to learn it, okay? But we also want to look for the optional comma that is right next to it, because that really needs to go to. But sometimes it doesn't have a comma, like in this case. So we've specified comma, but then we can make it optional. And to make something optional, we specify a backslash equal to. That makes it optional. There we go. So now we have a particular way to look for things that we want to get rid of. Let's go ahead and do this. Okay, so what I'm going to do is I'm going to copy this into a buffer first. So Control Shift C is going to copy into the buffer, and then what we'll do is we're going to specify the entire program, and it will say substitute, and now I paste that original search string into here with nothing. And the G is kind of optional. We don't really need it, because in each line there's only one console.log, so I don't really have multiple console.log instances to remove on each line. But the G doesn't really hurt either, so I'm going to put it here, and then we press the enter key, and voila. It does leave some empty lines, okay, not really pleasing to the eye, but at the same time, I got rid of all the console.log at the same time. So this is the power of Vim, VI, or NVim. They're all basically variations of VI, which is the ability to use regular expression. What I just did was the specification of regular expression. Now, do you need to know this to pass this class? The answer is absolutely not. Okay, this is pretty advanced type of thing. You don't have to know how to do it, but just in case anyone is wondering why I keep on using Vim, this is one of the main reasons I can do stuff like this. Now imagine your program is several hundreds of lines long, and you have to do something like what I just did, throughout hundreds of lines. I'm not going to do it by hand. I mean, that's for sure. And this particular feature, using regular expression in VI, enables me to do just that. Alright, so I'm going to save this code, and now we're going to talk about a debugging technique, which is also not in the notes, and that's why if you want to take notes, please go ahead and take notes. Alright, so if you want to debug a program, you can also just say node, but this time I'm going to say inspect. Okay, so the word inspect is very important in this case, because what it's going to do is it's going to start out the program, and you can do a few things after we started the program. You can do a list, and I thought that is how we do it. Obviously not. Okay, so let's go ahead and find out how to do this. I'm fairly new to the debug capability of Node, and that's why sometimes I thought I knew how to do something, and I end up not really knowing exactly how to do it. right. All right, so I'm going to put in the URL, somewhere on the screen. Um, Let me just kind of drag this over so you can see it. There we go. So if you want to learn about the debugger of Node, which I think is going to be very useful in this class, you just have to go to this particular URL, which is https://node.js.org/api/debugger.html. Alright, so now that we get here, we can actually work on some code. So this is also why I have the background music, because when I have a little snafu, I'm not gonna re-record the entire thing. So I'll have you guys kind of enjoy the music while I work this out, right? Alright. So it doesn't quite want to do this. Huh. That is not what I expected to do. So I must have done something incorrectly to begin with. Pretty sure this is how we are supposed to start it, and this time it didn't work, even from the first time. Free payload does not look like JSON. Huh. And oh, I must have done something to the program itself, so it didn't load to begin with. Alright, so let's fix that problem first. Because it won't even work if I just did a node if.js. So according to this on line 33, I'm missing a close parenthesis. Alright, so my bad, because I actually broke the program when I did something to it. Oh, okay. This is rather it's funny, but it's not really funny, because I also removed the console.log at the end of the entire program when I did this search and replace. I really should not have done it to the entire program, because I really should have done it only to the subroutine itself, but not outside, because now I have lost the very last 3 lines of console.log, which is what I need in order to call max3 to test the few things that we wanted to test. So I cannot remember the exact examples. I think one is 627 or something like that. And you can see how it highlights the entire thing, meaning that if I were to do that, search and replace, that's what it would do, and the last parenthesis is not selected, and that's why only the last parenthesis was left over from the whole thing. And I'm pretty sure 555 is one, and the last one I cannot remember either. So we'll go ahead and just say, it is the middle one that is the largest. I think it's 565. Alright, close enough. There we go. Alright. So now let's go ahead and try debugging again. Okay, because it should work. It should have worked the first time. And if I just do a run and do a continue, it did not like it. It still doesn't like to it. Okay. Okay. So I must have done something really kind of funky that makes this not working, because that's what I'm reading on the other side, and I have tested this a little bit earlier of how to use the debugger. Darn it. Okay. Alright, so I'm going to move on and not to rely on the debugger, at least not until I figured out why it is not working. Alright, so next item would be loops. Okay, so the previous one is a conditional statement, so we're going to get into a loop now. So when we get into a loop, okay, so let's go ahead and look at another program. This one is find prime factor. Okay, and I'm just going to say find PF for prime factor. So this is the code, and this is an example also in the text notes. So we'll go ahead and say this is find prime factor, and n is our parameter, and then we say let f, which is the potential factor starting with 2, and then we have a while loop here. Oh, did I use a while loop? Hmm. Okay, let's not use a while loop here because I think I only used the for loop. I might have made a mistake in the notes. Sorry about that. I'm just looking at the notes here just to be sure about what I used in the notes. All right. So we got conditional statement, we got the for loop, the comma expression, nested control structures. Okay. Find a prime factor. Okay, I did goof. So I goofed because I used a while statement here, and that is actually, it's actually okay. I'll tell you why it's okay. Because every for loop is a while loop, and every while loop is also a for loop. The difference is whatever initialization is before the while goes into a particular section in a for loop. Whatever condition you need to stay in the loop goes into a particular section in the for loop. Whatever operation that you need to do per iteration or the post operation goes to a particular section. And in this case, there's nothing left to do other than this particular post operation. So I'm going to translate this into a for loop in the example here, because I want to only introduce one single looping structure, because then you don't have to worry about, okay, should I use this one or should we use the other one? No, there's only one. Okay, so let's go back here, and this time I'm going to use a for loop to implement the entire thing. Now we do need f that to be outside of the scope of the for loop, so we cannot use let f inside the for loop. So now we say for the initialization is we initialize f to 2, which is the first prime number. 1 is not a prime number. Yes, yeah, I looked up the definition. 1 is not a prime number. The first prime number is 2. So how do we stay in the loop? There are two conditions to stay in the loop, and we're going to connect those with an AND statement, with an AND operator. I shouldn't say statement, it's an operator. So the first condition to stay in the loop, so I'm going to specify this and this, and then the post operation is to increment f. So f gets f plus 1 plus f, f plus plus, they would do the same thing, but since I have not introduced the increment operator, I'm not going to use it. Okay, to stay in the loop, there are two conditions. One is pretty obvious, and the other one is not as obvious. So let's talk about the obvious ones first over here. We want n mod, which is this percent symbol f, to be non-zero. Okay, not equal to 0, like that. So in this case, this is the mod operator. What looks like the percent symbol is called a mod operator. A mod operator is the same thing as just looking at the remainder of a division. So this time we are dividing n by f, and we're looking at only the remainder. If the remainder of the division is non-zero, that means f is, that means n is not a multiple of f, which also means n is not wholly divisible by f, which also means f is not a factor of n. So if f is not a factor of n, we want to move up f to another potential value. And then this one here is the one that is not so obvious, because we want f times f to be less than n in order to stay in the loop. The reason why this is the case has to do with a mathematical theorem, that if you have a product, okay, let's say C is the product of A and B, and A, B, and C are all non-negative, it basically means that one of those two, A or B, at least one of those two, A or B, is less than or equal to the square root of C. Okay, so I kind of described that in the text version of the notes. And the funny thing is, I got nothing to say here. I really got nothing else to do in the body of the loop, because the only thing I need to do per iteration is already specified as my post operation here. So, and now we can get out, and then we say if f times f is greater than n, then we know that n itself is a prime number. So f equals to n in this case, and then else there's nothing else to do. That's okay. It is perfectly okay to have an else branch that specifies nothing. And you might say, but isn't that just kind of wasting space or processing time? It doesn't use up that much, space for one, and then in terms of processing time, I really doubt that it would use any processing time. What it does is it does leave you a place to insert some code just in case in the future you want to say, I actually have something to do in the else branch. So, that would leave us something here. All right, so now we're gonna test it. We say console.log, find prime factor of, let's try 2 itself. Okay, 2 is a prime number, and then we'll try a composite number like 6, and then we'll try a number that is a square of some prime number like 9, and then we'll go ahead and try some kind of prime number again, let's say 11, and there we go. And then we exit the program, and then we try to run it, and it finds that 2, 2, 3, 11, and the second 2 is a factor of 6. The 3 is a factor of 9, and then 11 itself is a prime number. So it does work. Okay. So now we're going to go back, and then this time we're going to insert some console.log at some really weird places, just so that we can understand how the looping is going to work. Okay. So let's go ahead and do that. All right. So we're going to insert console.log at the strangest of all places, right? So we're going to say here, this time I'm not using backtick because there's no need to use a backtick in this case. So I'll just say that this is, initialization, because I want to make sure that people can see that initialization only happens once before we get into the loop. And then before we specify the actual condition that we can use, that we're going to use to specify how to stay in the loop, I am going to put this entire thing in its own parentheses or pair of parentheses, and then we're going to put in a console.log right here. Okay, so this open, this is another reason why I like Vim, is it matches parentheses for me. So now we're going to insert a console.log here. And this time I'm going to use backtick because I want to see, this is checking the condition. So we're going to say check condition while. And this time I want to print what is n and what is f at this point of time. So n doesn't really change, so I don't really necessarily need to print the value of n, but I'm going to do it anyway. So we're going to say n equals 2. From the syntax highlighting, you can probably guess that n equals 2 is going to be printed verbatim, which is just n equals 2. So if I want to print the actual value of the variable n right here, and well, it's not exactly a variable, it is a parameter, but it can be seen or treated as just a variable. So if I want to put it here, that's not going to work because all it's going to do is to print n equals n with every single line. Okay. And f equals f, like so. So we're going to do just that, just to see how it's not going to work, right? But we also want to have one more here, which is console.log, and this portion here is the post operation, and I use just post op, in my notes to signify the post operation. So we're going to check this out and see what's going to do. Remember the principle of not putting in too many changes at the same time. But before I go any further, I am going to adjust the indentation stuff, okay, so that it looks better, so that everything kind of lines up. And this is yet another reason why I like Vim, because if you just say, equals equals, it lines up, things the way it's supposed to. Okay, and this equal sign can go here. So this way, things, I think it looks better than what it was before. We have the initialization, which is consisting of only this line here, and then we have the loop condition, which is consisting of these 4 lines, and then we have the post operation, which is specified by this particular line here, and there's absolutely nothing in the loop body here. But you know what? We're gonna say something here. So console.log, and we are in the body of for loop. Okay. I mean, I put it here just so that you can see the ordering between initialization, check condition while blah blah blah, post op, and the body of the loop, because post op is right after body of for. Okay, that is what I want you guys to be able to see. The rest I'm gonna leave it as is, and then we test run the program again. And this time it looks kind of messy, right? Because that's what it's supposed to be. So when I'm only using 2, you can see that it exited pretty much right away. It checks the condition and it becomes false right away, and that's why we exited, and 2 is the answer. When we were testing 6, it actually also exited right away because 2 is indeed a factor of 6. When we tested 9, it had to go for at least 1 iteration of the loop. It went for exactly 1 iteration of the loop, so that f increments from 2 to 3, and then it exited the code. But it's really hard to see because it's not printing out, we are checking the condition when equals to blah and blah. So it's not really giving me the actual value. So the backtick was not working, at least not the way I want it. So now we're going to go back and fix it. So as it turns out, inside a backtick, if you start with $brace, then you can specify an expression that is going to evaluate, and then whatever the value is after the evaluation is going to be the string that is going to be, it will end up as part of the string that is backtick or back quoted. So I will do the same thing with f here. And you can see from the syntax highlighting that it is different, right? Because when we use $, and then a brace, it is telling JavaScript and say, hey, what is inside this pair of braces here is an expression to be evaluated, and then whatever the result is will become a part of the back quoted string. So that's why it's going to be handy. So we're going to just do these 2 minor changes, and then we'll test the program again. And this time it makes more sense because now we can see it checks the condition and it exits right away. It checks the condition, it exits right away. And then when we have 9 as n, it checks the condition. It did not exit right away. It went to the post op and then checked the condition again. When f equals to 3, that is when we exited the loop, and the result is 3. And for 11, it even had to go for 1 more iteration because the square of 3 is 9, and 9 is still less than 11, and that's why it could not exit just yet. However, when f is incremented to 4, then 4 squared is 16, and 16 is not less than 11, and that's how it exited. Alright, so you can see how this is kind of rather useful. It gives you the ability to really kind of check what is going on here. And then some people will say, but I want to see the condition, I want to see the value of these conditions as we go through the loop here. Well, that is actually possible. It's just that you're going to need to do some editing here. So I'm going to do it for you, okay? And we'll go ahead and break it into 2 parts. Well, let's see. We can do it in 1 part. We can do it in 2 parts, 1 part. I mean, it's about the same for me. Okay, let's do it in 1 single line because it looks neater that way. Okay, so this time we want to print out the actual evaluation of these conditions. So someone is going to say, but Tech, you're going to need the dollar and then the brace. Yes, we do. However, I still need the expression itself here, so that when I look at the console.log output, I can actually see what the true or the false is corresponding to. So I'm going to keep it here, and then we'll say is. Then we use $brace to actually specify the condition to be printed, to be evaluated, and then the same thing over here. is, and then dollar brace, and then this time is n mod f does not equal to 0, and then close brace, and we need a back tick all the way here, and then a close paren all the way out here. So this one does not quite tell us what is the result of the conjunction or the AND, but it does tell us what is on each side of the conjunction. Okay, so let's check it out. Okay, once again, we are going to evaluate it one at a time, and I have one error here. Okay, and I'm not going to fix it. Okay, I can see exactly where the error is, but I'm not going to fix it because I want to show you what error message you'll be getting when you step onto something like this. Okay, and then we'll go back and fix it. All right, save it, and remember, this is not going to work. All right, so it complains, and the error message is saying console.log is not a function. What do you mean by it's not a function? We have been using it for a while. Why is it not a function? And the most important point is we know the problem is around line 9, which means it may not be line 9 itself. It may be the line before, maybe the line after, but it's around line 9. Okay, so this is really important because when Node reports an error, okay, so when you try to run Node and it gives you an error right away without even actually running the, well, I mean, it did run the code, but it complained about a certain line. The actual problem can be on the line that is quoted, but it can also be on the line that is before the reported line. So in this case, it can be line 8, it can be line 9. Let's go back into the program and find out what is happening. So this time I'm going to turn on line numbers just so that we can see which one is line 9. This is line 9, which is where the node is failing. The problem is we are missing a comma here. Because remember, we want to turn this entire thing from line 6 all the way to line 10, excluding the semicolon, into a comma expression. And forgetting this particular comma here means that these two expressions are no longer related by a comma, and as a result, as a result, JavaScript says, I don't know how to handle this because it doesn't make sense to me. With a comma, it's gonna make sense. Okay, so we'll go ahead and save the program and check out its execution. And this time it's even better, right? Because now we can see when n is 9 and f is 2, then f times f is less than n is true because 4 is less than 9, and 9 mod 2 does not equal to 0 is true because 9 mod 2 is basically the remainder of 9 divided by 2, which is 1. 1 does not equal to 0 is also true. So we got true and true, which means the conjunction itself is also true, which also means we stay in the loop. When we stay in the loop, we execute the body of the loop, which is, which only got one console.log to print, and then we get to the post operation, which in this case increments or adds 1 to the value of f, and then it goes back to check the condition again, except this time f equals to 3 because the post op is what is incrementing the value of f from 2 to 3. And then when n equals to 9, f is equals to 3, then we know that 3 times 3 is less than 9 is false because it equals. So in the case of a conjunction and the left hand side is false, it does not even actually bother to evaluate the right hand side, which turns out to be false too, because when the left hand side of a conjunction is false, the entire conjunction is guaranteed to be false already. So in reality, it doesn't actually go to evaluate the right hand side. This is called a short circuited evaluation of a condition. We are going to make use of this feature at some point in time, but right now, it is not super duper important. Okay, so I have pretty much talked about everything that I want to talk about, which are basically the two control structures, right? So we have the conditional statement, which is a one-shot thing, and then we have the concept of a loop, which is not a one-shot thing, okay? Because it can go for no iteration whatsoever. It can go for several iterations. Now, if you want an example where it doesn't go for even one single iteration, it is when n equals to 2. Because in this case, you can see that we went through the initialization, we checked the condition, right? And when we check the condition, at least one side of the conjunction is false. It turns out to be both false in this case. It doesn't matter, okay? Because if at least one side is false, the whole thing is going to be false. And then you can see that it did not go through even one single iteration, because in this case, you don't see body of 4 appearing even once. If you don't see body of 4, you're not going to see post op, because these two are buddies. Okay, you can you either see both of them or none of them. You never see just one of them appearing just once. Okay, and post op is the one that is inside the parentheses right after 4, and then body of loop is inside the block of code after the 4, followed by a pair of parentheses. So it looks a little awkward because we specify the post op syntactically before we specify the body of the for loop, but in terms of execution, we actually execute the body of the for loop before we perform the post op, and then we go back and check the condition again. Alright, so I'm hoping this gives you an idea of how a conditional statement works and how a for loop works. Now, obviously I have not enumerated, I have not listed every single way to use a conditional statement and a for loop, and how to nest them, and so that one is embedded into the other one. It's impossible to do that, okay? But on the other hand, you can implement your own examples. You can actually write your own code, go through the same kind of exercise that I'm going through right now, and then just use that as an experience so that you can confirm that your understanding of these control structures is correct. Having said all that, I really should be ending today's lecture, but I kind of feel obligated to go back to the notes. First of all, I'm going to change where I made a mistake, which is using a while loop instead of a for loop. So as I said, okay, the let f stays here, and then we use for, and then f equals to 2 is the initialization, and then we specify the condition to stay in the loop, which continues to be exactly the same thing as it was in the while loop, and we don't need that parenthesis here. And then we have to specify the post operation, which is f gets f plus 1, and then close the parenthesis. So this close parenthesis is matching this open parenthesis all the way over here, so we don't need the body of the for loop to specify f gets f plus 1 anymore. So this would be the correct version. And someone looking at this code is going to say, but Tack, the syntax highlighting is not working, right? You are correct, it is indeed not working. So what I'll do is I'm going to select this whole thing, and I'll show you how I put in all the syntax highlighting. There's no way I would do that manually. There's a little add-on in Google Doc. It's initializing right now. It's called code blocks, and this is how I perform the syntax highlighting. It has several themes that you can choose from. This Arduino Lite turns out to be kind of the most pleasing to my eyes anyway. So I just use this one. I mean, it's a free add-on in Google Doc, so if you want to, you can just go ahead and attach or add this add-on to your Google Doc and just kind of play with it. I just find that if you want to take notes in terms of writing code and whatnot, this is actually rather handy. Alright, well, the reason why I got back here is not only to fix the mistake that I made here, which is using a control structure that I had not introduced earlier in the earlier section, because this is supposed to be an example of control structures that were already discussed in this particular module. The other one I want to talk about is finding the maximum. This is the quote-unquote straightforward way to do it. Okay, it uses a very basic control structure that exists in C, C++, and so on and so forth. Okay, so this code can be translated into C, C++, Java, PHP, and so on with very minimal changes. Okay, it should work in all of those programming languages for the most part. And then I went a little crazy to talk about using the for each, which is a method of every single array. Okay, so we'll get to this one for sure because it is a very useful method of an array. Okay, and then I went a little far, okay, and use a cheater version, which is to sort the array first in a reverse order, and then I just extract the first element of the sorted array in decreasing order, which is not efficient, but it does work. And then I went for the even worse implementation, which is to use recursion. Okay, so we have already talked about subroutines. Okay, and this only relies on subroutines with 3 additional things that were not talked about before. One has to do with a initialized parameter, which is basically saying if this is missing, we will assume it to be 0. Okay. The second one is how we can define a function within a function, which basically means function max is only visible and it can only be invoked or called by find max. And then the last one is the most mysterious one, which is inside the function find max, I'm invoking find max itself. Okay, so this one is something that is really kind of intended for people who already understood recursion, and they just want to look at the recursive implementation of this particular subroutine in JavaScript. And then the last one is one that is going to make mathematicians happy, but it is not really efficient coding because it is using the definition of maximum, which is this kind of mathematical equation here. No, this is not what we are supposed to learn in this class, but I just want to throw this out, okay, because in case someone is curious and want to say, I don't know what find does, I don't know what every does, you know, there's a very easy way to find out. It's called, guess what? Google. Okay, if you just Google JavaScript array find, you will probably locate the description of the find method for arrays in JavaScript. If you mention the same thing with every, you'll find that page. So that is not intended for beginning programmers. Okay, so if this is the first class where you actually write any code, there's a place you're supposed to stop, which is right here. Okay. On the other hand, if you have some programming experiences, you have taken some programming classes like CISP 360, 400, 430, and so on, and you just want to say, well, I kind of get programming already. I want to see what else I can learn about arrays or how to process an array in JavaScript. As it turns out, there are some really interesting things that you can do with arrays that you really don't have equivalences in C, C++, for sure. I think Java may have some of these, but it doesn't get to the same extent of JavaScript. So JavaScript has some really cool features for experienced programmers to exploit. So I'm hoping this gives the more experienced people also a chance to learn something new, and at the same time, for people who are just getting into programming, they can stop here. I mean, I'm not gonna throw these out I'm not gonna use anything past this point as a criterion to pass this class, or to even to get a good grade in this class. If you understand everything up to here and you're able to apply all of that stuff, to me, that's good enough. Okay, but there are some people in this class who might have some programming experience already, so those people can move on and read all the other sections in section 6. Alright, so I think I have been yakking long enough already, and I really want to find out why the debugger doesn't work on my computer. So I'm gonna stop the video right now and get it uploaded to YouTube. Alright, so look forward to the next one, because I'm gonna be able to find out why the debugger is not working and then introduce you to debugging a program using a debugger.